Okay, guys, I'm going to go over the handout that says gas law equations, and I'm going to go ahead and do problem 1 for you on the second page. So it looks like this. So with that, we're going to use the ideal gas law, and that is the original P1 V1 over T1 equals P2 V2 over T2. Well, if we're reading the question, it says the one that's given is 100 milliliters of saturated gas volume measured at 25 and 750. And then what we're finding is the new saturated gas volume at 37 degrees and 760. So we're asked to find the new volume. So we're actually looking to solve for V2. Well, arranging to isolate V2 on this side by its own, we have to multiply by T2, so it'll cancel out, and divide by P2, so it'll cancel out. And what we do to one side, we have to do to the other. So therefore, solving for V2, we're looking at T2, P1, V1 over P2 and T1. So now we're going to look at which variables, what the values are for each variable. So V1 from your given equation is 100 milliliters of saturated gas volume. So for V1, volume 1, 100 milliliters. For P1, because the equation said that it was saturated, you have to take out water vapor pressure. So the table for the corresponding water vapor pressure is in page 190, which is in chapter 4 of your book, of your textbook. But also, if you look here at the equation, it gives it. Okay, so it's given at 25 degrees Celsius. pH2O, which is water vapor pressure, is 23.8. So now what we have to do then is subtract the water vapor pressure at a temperature of 25 from the measured pressure 1. So in here I would put 750 minus 23.8. So my P1 is 726 millimeters of mercury. Okay, so 726 is my P1. T1 was given at 25 degrees Celsius. And then anytime we're doing gas law equations, we have to convert from Celsius to the Kelvin scale. It says that temperatures must always be in Kelvin. So Kelvin is a temperature unit of measurement used in scientific formulas. So here we just add 273 to degrees Celsius. So 25, which was given, plus 273 is 298 Kelvin. So this is our T1. P2 was given at 760 saturated at 37 degrees. So that's where we have to take into account, looking at the chart and looking on your paper where it's given, water vapor pressure at 37 degrees is 47 millimeters of mercury. So therefore, P2, 760 minus 47 is 713 millimeters of mercury. So this is P2, 713 millimeters of mercury. Then T2 is body temperature. So 37 add 273 to convert it into Kelvin, and you get 310 Kelvin. So now we have all of our variables, and we're going to put those into our original equation to solve for V2. So now we're going to type in T2. Okay, so here I'll write all of these down so we don't get confused. 310 times P1 of 726 times V1 divided by P2, so the 713 times T1. So our T1 is our 298. So I'm going to put that into my calculator here. And I get 106. I get 105.9. But since we were given whole numbers, we're just going to round up and stay in whole numbers. So now the V2 that I calculated is 106 milliliters. 106 milliliters. So that is the answer. So this is using the ideal gas formula to solve generally for volume 2. These equations are used mainly in pulmonary function testing. So the machines usually do it for you, but this is the theory, and this is how to get those equations. Thank you.